Howdy everyone. So hopefully you can hear me. Yeah, hope you're all taking care of yourselves right now. Really appreciate you all coming along to this webinar despite what is happening in New Zealand right now. As the title suggests, the webinar is about the future of engineering in New Zealand. So we've invited engineering leaders from the electricity, transport and automation industries to give their takes on what the future might hold for engineering in New Zealand. Some of the things that they'll cover today include emerging trends in engineering, disruptive industries, and some key skills that young engineers might need going forward. At the end of the webinar, there will be a question and answer session with the three speakers. So if you think of any good questions along the way, send them through any time on the Pigeonhole link to your left. The webinar is organised by Engineering New Zealand's Young Engineers Group, Young Transport Professionals and Young Water Professionals. Both the Young Transport Professionals and Young Water Professionals are separate groups from Engineering New Zealand. So if you have some sort of interest in transport or water, I highly recommend that you join these groups. All of these groups are organise in-person talks, networking events and mentoring opportunities, and they're free to sign up, so I'll link the Facebook pages in the chat sometime. Our first speaker for today is Andrew Renton. So Andrew is the one and only Senior Principal Engineer at Transpower New Zealand, the owner and operator of the national grid. One of his responsibilities is to identify and understand emerging technologies in the electricity industry and communicate that to leaders within Transpower and the wider engineering community. So I'll pass it over to Andrew now.
Hello everyone, and thanks Elvin. And just before I go any further, can someone type us up in the technical issues? Can you all hear us? Anybody typing? Excellent. Thank you guys. Many coming through. All good. Right. I'm going to give you a quick romp through kind of the future take on the electricity transmission perspective. And this is there engineering? If you're an engineering job, do you have an engineering future in the electricity space? So these are the messages I'm going to leave you with. Yes, there is work to do. It may be being done in a different context. That might be different work to what's been done before, but there's still the same requirement. Lots of smart people with lots of smart skills all working together if we're going to achieve the energy outcomes we need. Fundamentally, I'm going to pose you three questions, which is, do you believe in climate change, do you believe enough to do anything about it, and do you believe enough to do anything about it by 2050? And if the answer to all those is yes, you can follow the black line down on the bottom left-hand corner picture, because that's what we need to do with regards to the amount of CO2 that's put into the atmosphere in New Zealand. If you're following that trend, then the New Zealand context in the top right is really interesting, because more than 50% of our emissions are coming from agriculture. So what can we do compared to everybody else when everybody else's biggest emissions are in the transport and energy sectors from generating electricity? You can see that in the New Zealand case, that transport and manufacturing are the two items that are the big levers and relatively straightforward to pull. Not electricity, where an awful lot of our electricity comes from hydro and wind, geothermal resources now, which are low or zero carbon. This little picture here is just an idea of giving you a scale of the energy that is used in New Zealand. Orange at the top is how much electricity is used, and it kind of shows you where it is predominantly used. And then oil and natural gas are the two other major energy vectors, and where they're used in the economy. And you can see that there's more energy used out of oil and gas than there is in electricity. So if we're going to shift to a lower carbon space, then there's an awful lot of work to do in removing the carbon from oil and the energy use in those sectors and transitioning them across to electricity. And that's what this shows here. So the ramp up that you see from 2020 onwards is how we are going to move more of the energy consumed in New Zealand from a carbon base to a non-carbon base. So about 25% of the total amount of energy used in New Zealand is from electricity, and that's going to need to move up to about 56%. And the graph down in the bottom corner, bottom right corner, is just focusing in on transport. Land transport produces about 20% of all of our emissions, and of those emissions, 13.5 million tonnes of that is coming out of the light vehicle sector. So light vehicles is anything under 3.5 tonnes, and you can see that getting hold of that is the electrification of that sort of transport is the trick to pulling a lot of New Zealand's emissions down relatively quickly. So what does that mean? Because the energy still has to come from somewhere, it means that there's going to be a lot of more generation built. So currently New Zealand has about 9.2 gigawatts of electricity generating capacity, and depending whether or not the aluminium smelter remains at the bottom of the South Island in the long term, we need to either install 14 or 15, we need to reach 14 or 15 gigawatt hours, which is obviously quite a substantial increase in generating capacity. It will be coming from a mix of wind and solar and everything else, but that generation will need to be built. On top of that, we'll need to take care of all of the generation plant that will be retiring between now and 2050, so that will have to be constructed as well. And then obviously manage a lot of the a lot of people will say that's a big ask and can't be done, so here's a little chart for you. From 1920 through to 2012, this is New Zealand's electricity consumption. And when your grandparents, or possibly some parents, were all getting a fridge and a washing machine and a TV back in the 60s, electricity consumption in New Zealand went up from over 100% to 12%. And what we could do at that point in time was build the power stations listed up on the right-hand side. So over the space of about 20 years, we built about 35 power stations, predominantly large civil structures, and a couple of thermals and a geothermal power plant as well. We also had to build...
Andrew, could I just stop you for
Sure.
1 second? Sorry, we've just had a few people who have said that your sound's a bit funny. Could I just ask you to slightly move your microphone away from your mouth and then just say a few more words?
How's that?
Sorry to interrupt.
Is that right?
That sounds good.
So, can we do this in the future? The answer to that being yes. Built all those power stations, about 35, and we built them over the space of about 20 years, and we built them and built the grid at the same time. Now, of course, the context was different. This is a picture of Auckland around Mount Roskill for anybody who knows it. When a lot of this was built in the 50s and the 60s, it was all green paddocks and not much else. Today, society has a different expectation of us. They are wanting us to not only provide energy, but do it in a sustainable way, make sure that the environment is protected. So the context in which we operate in doing these things has changed. Some of the work we do is going to be different. We're still making power stations, but they might be solar power stations rather than hydro power stations. Because there'll be a lot of embedded generation network. So new devices like StatCom, VCCs, and highly density power. The way we deliver it is going to be different. Sorry about that. You're still scratchy and patchy.
Yeah, apparently I can hear you perfectly fine, but there's a few people that are saying that they're also having issues. So maybe just keep going and we'll see how we go.
So the types of tools and skills that we're going to use are different. During the 1930s, today. There's different organisations. Since 2013. I've been working recently with organisations like Rockos, Boston Dynamics, Massey University, and a whole bunch of
Andrew, can I maybe ask you to turn your webcam off, and then if I can ask Alex and Alvin to also do the same, that may actually just help with connection. And then maybe Andrew, if you could also just turn your microphone, try again, and we'll see how we go. I can hear you perfectly fine, but there's quite a few comments there to say that we can't hear you.
Interesting. I've got you and coming through perfectly as well. It's nice to know what's going on. Anyway, just trying to say in this space here, we use a lot of new AI and new technology as well. And also working with a whole bunch of different people. So it wasn't just the landowners we deal with today. When we're using drones, we're interfacing with a whole bunch of people like the Airline Pilots Association, Air Traffic Control, and a whole bunch more. It is not the same as it is. And if you want to find out a whole bunch more of what else we're doing, it's all published here in these reports. And that was my presentation.
Cool. Thank you, Andrew, for sharing your experience about the new AI and technologies, and also by achieving zero carbon by 2050. And then now we will have Silu, the chief engineer from Waka Kotahi. She's a chartered civil structural engineer with over 30 years experience, and then she has a strong focus on developing innovative and cost-effective solutions for transport infrastructure problems. So she will talk about how the young engineers' contribution towards the transport solutions for a thriving Aotearoa.
Hi everyone, I hope you can hear me, and I also heard the sound didn't come through really well, so I'm interested to see how you hear the sound at the other ends, and also should I turn the webcam off too. So Selena, do I sound okay?
Yeah, you sound great to me. From my perspective,
so
yes.
I think I'll turn the webcam off in case it has...
Sulo, do you want to keep your webcam on, and then Andrew and Selena can turn theirs off, and then it's just yourself that's on screen?
Okay, yeah. Good afternoon, everyone, and I first thank young engineers, particularly Selena, for inviting me and giving this wonderful opportunity to talk to you and share some of my thoughts. And as you see, the title of my talk is about young engineers' contribution towards transport solutions for a thriving Aotearoa. And when I think of future of engineering, particularly in New Zealand, what comes to my mind is the young engineers, and when I say engineers, particularly the young professionals, who has the huge opportunity here to not just take the transportation to the next level, but make a huge difference to New Zealand as well. So this slide shows the importance of young engineers' contribution. And I want us to think, particularly the participants here, most of you are early in your careers, and think about the difference our transportation solutions make, not only the current and the next 5-10 years, but for the next half a century and further. And I think that's really, really important. I think we need to look at this future transportation solution in the context of key issues. I think everything we do here, transportation and all the other infrastructure, are for people. and for the people and the people. So what's important here is the people. And when we talk about the people, it should be the solutions and all the things we are addressing in terms of opportunities and challenges should be inclusive and making sure the communities have the opportunity to excel and prosper. So that's also very key. Our focus should be very diverse and inclusive when we come about solving problems. And I think we often talk about solutions in terms of outcomes, and that's really key for current day problems, because if we solve the problems of what we are facing today, we miss the opportunity of the future. So when we are looking at problems of today, it should have the long lens for the future as well. So my thoughts are around what we are trying to do in the transportation sector and what's really important and how one can go about, especially the young engineers can go about contributing for solutions. I think in terms of outcomes, it's really, really important that we want a safe, secure, and resilient transport systems. So when we look back, when we did the motorways and all the other transportation schemes in New Zealand, the focus wasn't about safe, secure, resilient transport system, but it's about providing some means to get people and products to A to B. But now, when we look at transportation solutions, our focus is more about not just moving A to B, but also providing a system-wide thinking and solution so that it's not solving the transportation problem, but it's solving the wider issues in the communities. So it's really, really key that the security and resilience are built in our transportation systems. I think Andrew touched upon this really well in his last presentation. Anything we build and thinking of building and maintenance and all that should be looking at our environment. And the concept of clean, green and less emissions are very critical these days. So our approach to the transportation solution should be taking into account of the climate changes, emissions and all the other issues. And importantly, the preservation and restoration of our planet is also equally important. So the message here is the outcome should be focused on system-wide issues and providing transportation solution to solve more holistically rather than just moving things and people one A to B. I have put here some thoughts around future of transport, and key question that one would ask in the past, I mean, the main transportation is roads, and we had ports to move things on sea and then air traffic as well. But now we are more into active modes, shared paths, and there are other modes coming up as well. So the new traveling modes needs to be looked at. When we are building today or thinking of creating something now, what would be the new traveling modes is really a key question to ask. And interesting, we have seen the shared services, public transport and all that taking a new turn. The kind of services and operating models will emerge in the future becomes a question. And importantly, how will it change our urban space? I think the current environment is a good start reminder for us to remind us the urban space changes and how that affect the transportation is another question to ask, because anything we build is going to change. And that should be the urban space, and how the changes would affect the urban space is a key thing to think about. I think the lockdown and COVID have reminded us that the road traffic of the future, there is a potential to think about how it will affect the transportation problems. So I have put down some key questions that we should be asking when we are looking at some of the transportation wider problems we are trying to solve today. I might not have all the solutions here, but I thought it's at least by posing the questions, together we can keep thinking about this. So some of the technology that we are seeing as emerging technology are driverless cars. We have seen them, and it's hugely popular now. And they have significant effects on the system-wide outcomes we are looking at. The deliveries drones for dropping things, and that's also emerging. The underground structures, roads, trains, the maglev trains, Hyperloop, and the list goes on. So the emerging technologies effect on transportation solutions is a key thing, and we should not lose the focus on them. So they should be helping us to get the outcomes we are seeking. I think it's really, really important we should remind ourselves our contribution to this in this space. So it's not a particular person or a organization has a sole responsibility. For me, it's a collective responsibility. We have individually, by advancing our knowledge and experience and contributing to the wider outcomes is key. So we have a personal responsibility as young professionals to contribute to these kind of discussions and also becoming part of the solution. And then we have a collective responsibility at our individual community level and also through professional bodies like Engineering New Zealand, particularly the young engineers, and various other technical societies in New Zealand to actively participate and contribute to the solutions. And of course, the Waka Kotahi New Zealand Transport Agency and other transport bodies have a greater role to play as well. So when the pictures show some of the other living creatures in our beautiful New Zealand, so we should be mindful of our solutions, holistic, inclusive, and looking after the future for everybody. Thank you.
Oh, thank you, Sulu, for great presentations about, I like your idea about the innovative solutions to the transportation system and also the emerging technologies that Waka Kotahi is looking into. Thank you very much. And then next we will have Matt Bishop from BVT, and he's the managing director and then where he will talk about the role of engineering in the automated world. So welcome, thanks to Matt.
Thank you, Selena. I'm going to start slow and see how we go with bandwidth. Feedback there, please, folks. Kia ora, and good evening. I am the Managing Director at BVT, and BVT is the interiors engineering firm specialising in seismic design and compliance, and I'm also the Chief Entrepreneur at Penguin, which is a software platform, an online software platform for buildings. Very clear audio. Good. We'll carry on. This is purely coincidental, but my first slide is actually also about transport. But I'm going to go back to the 1850s. And this is Clementine Massano's Impulsoria. and it's a very well constructed engine for the transportation of train carriages, and it had a power output of 2 to 4 horsepower, depending on how many horses you put on it. And the reason I wanted to show this is because at the time that Clementine put this together, it made good sense. At that point in time, this machine was capable of pulling more carriages faster than the steam engines of the time. It got built, it got trialed, and then this happened. This here is a quick graph of steam engine power since 1840 up to about 1890. And what he didn't know then was that he was at the front end of an exponential curve. And once steam engines started to power up, the Impulsoria was relegated to the Wikipedia history pages. Now, I very much believe that we are at the front of an exponential curve as far as professional services are concerned. You won't find a lot of information about AI and new age technology in the engineering field, but we can see it very clearly in medicine, in law, and in accounting. And it's something that we really need to think about. To remain relevant, we need to learn how to adapt how we're working to what is effectively a new engine, how to put our engineering together in ways that mean we can leverage AI, we can leverage machine learning, we can leverage the very many tools that software engineers use these days. And we can use those to build new machines in factories, not physical factories this time, but professional services factories, just like engineers always have. There's 3 core parts that I'm going to focus on in this talk, and those are code, how to code, statistics, how to go back to some of our first year courses to understand how to use statistics to drive machine learning, and then machine learning and AI itself. We've been working on that with BVT, and I want to first off make a quick point that Excel is not a programming language. It's a tool that enables us to create some very complex calculations, but they're hard to read, they're hard to reuse, they're a poor crutch for learning how to do proper programming. But it turns out that if you know how to write a if function in Excel, you know how to write a VLOOKUP, you're actually not that far away from programming. And this is a tool that we've just started using over the last couple of months. It's called Google Colab, and it's a browser-based development environment, which then means that any engineer can basically step in and within the time it takes to open a browser, start coding. And we've used that quite effectively to create some of our baseline code environments, which we are releasing, or actually have released, into what's called GitHub, which is a extremely well-known thing to software engineers, but next to no knowledge of that in the professional space. GitHub is a tool that allows you to upload code and have it there open source so other people can use it. In this particular example, what we have on our Git repository at the moment is some libraries and methods for 1170.0 calculations and 1170.5 calculations. The one I've got on that slide going back there is a spectral shape calculation function. And effectively what that means is that if you import our import our code module into your Python code, you can run that spectral shape function and pull out your spectral shape factor, plus all of the other functions that are in the standard. And the reason that's important is that it then allows us, the amount of engineering ability, the engineering capacity that is being used at the moment to understand something like 170.5. Every engineer in every firm that is spending their time trying to understand how to work out an annual probability of exceedance, say, and every engineer that has to review and check those decisions, all of that horsepower wasted in trying to understand something that we're all supposed to agree on anyway. So using things like a programming method, like a open source engineering method repository, means that we get more time to focus on the wicked problems instead. And Sulu and Andrew actually focused on those really well. The upshot of that curve right back at the front of my presentation is, of course, massive amounts of carbon dioxide into the air. The technical advances that caused the Impulsoria to go out of business have led us to a situation where we now need to use the next generation of technical advances to get us to the solution. And that's me, ready and waiting for all of the questions.
Thanks heaps, Matt. That was really interesting, and you know, that three quite different talks, but common themes throughout. You know, you've got emerging technologies, how we as young engineers can contribute to solving some of these problems, and also climate change came up, I think, in everyone's presentation. So we've got a few questions that have come in. We've got 13 questions. I don't think we'll get through all of them, but we'll start going through them. So probably one for you, Sulo, if you're on the line. We've got, besides investment, is there anything else stopping New Zealand from having a world-class transportation system like Singapore?
I think that's a very good question in terms of when you travel in Singapore, it's reliable, safe. So yes, I think the important thing is clearly thinking about the outcomes and then working towards the things that make up those outcomes. So I think if we have the will, there is a way, and we will never have enough money. So I think if we set our sight to whatever we want to achieve, there is a way to achieve. And the technology is an enabler for us, and then there are other things we should be looking at in terms of helping us towards reaching those goals. So it may look like an aspirational goal, but if Singapore can achieve that, I'm sure we can. You know, if that's what we want, we will. Yeah.
Yeah, Matt, always comes down to money at the end of the day, doesn't it? But we've got another one here for Andrew, potentially. Doesn't a TY exit represent significant carbon leakage abroad, where the same aluminium will be produced by significantly more polluting coal and gas power plants? What do you think to that one, Andrew?
Certainly could, and certainly would if it exited. That's why we study does it stay or does it go scenarios, because whether or not it stays or goes is in the hands of.
Have you been? I mean, do you have regular conversations with Rio about that, or?
Transpower is the owner and operator of the transport network. Whether or not it stays or goes is a commercial decision for Rio. And
fair enough. Got another question here, potentially one for Matt, but probably feel free to chime in, Sulo or Andrew. Do you think that technical engineering will be offshored more, like a lot of drafting activity is now?
Yep, it very well could be, if you're talking about the standardized parts of the job. But I think there's quite a tension there between whether it is better to automate within the country or outsource the traditional methods of doing it, say. And I think a lot of the time, the common denominator there is that the work that was is no longer the work in the future.
I might have a different view. I would look at this in a way that how we can make these sustainable. So I think we should remind ourselves what we want is, we know, what we want in the future, and we should be prepared and willing to educate and prepare our younger generation towards that. So yes, we could export some of these offshore, but at the same time, we need to remember that for a sustainable future and long-term benefits, it should be delivered internally as well. So it should be balanced. So it's not just shipping off everything, but it should be in a balanced way. If we do want to help offshore, yes, but if we are receiving help, it should be looked in the way of not making financial benefits only, but making sure that that's the sustainable future for New Zealand.
I would offer
Do you think it?
two.
Oh yeah.
I would offer two. One, from a Transpower perspective, a lot of our projects are already a combination. For example, HVDC upgrades and things like that. We rely on offshore expertise from major suppliers and their own deep engineering knowledge and expertise for the manufacture of design or even problem analysis of special componentry. And then it's designed and built. Components of that are designed and built in New Zealand and large amounts. And the other side, even with all the smart tools that Matt was talking about, there is a business perspective in there that having an open source tool, there will be a liability issue that is attached to that. If I was to use an open source tool for calculating a spectral shape from ASNZS 1170, what happens if it goes wrong because there was a decimal point in the wrong spot? Who is legally liable for the thing that just broke? Is it going to be Matt? I just got an open source tool that gave me a number. And this is the challenge, and this is why you need smart engineers to actually understand what they're doing and understand the keys. And normally, when things get communicated wrong in engineering, people die.
I think, for those who couldn't hear, and Andrew was sort of saying about, there's a liability associated with using open source tools, and sort of who picks up that liability, and that's why we need smart engineers to interpret it. But what do you say to that?
Yeah, that's a good question. And the liability falls on the engineer that signs it off. It's what's called person in the loop, and you still need that person to be available to make those sorts of calls. So the great benefit of an open source tool is being able to compare notes, is to do peer review before you get to the pointy end of the project. So you know that you're using similar things like we get jobs where we get to develop design, and we get questioned on our importance level or our part category, say. And by that time, you're starting to lock in design, you're starting to lock in costs, and all it needed was a 5-minute discussion at the start of a project to agree on these things. So open source has advantages there, but the liabilities still have to fall with the person that's signing it off, and that's why engineers are always going to be there, but we're going to be able to speed things up quite significantly.
Thanks for that, Matt. I've got another one for yourself, Andrew. In terms of sustainable energy, what do you think New Zealand will be focusing more on solar and hydro electricity generation, or chemical energy such as hydrogen, or maybe looking at both?
Well, hydrogen is not an energy source of itself. It has to be created from somewhere. So the energy coming into the system, if you're wanting it to be renewable and low carbon, will be coming from sources such as solar, wind, wave, tidal, hydro, geothermal. What you do with that energy, and you convert it into something, it could be converted into hydrogen through electrolysis. You could grow trees and then turn them into hydrogen, but it's going to be a mixture of sources. But it will be predominantly, in the New Zealand context, a large amount of electrification for transport, etc. And then you'll have to look to where you get your chemical feedstocks. Are you going to manufacture and synthesize those, or are you going to get them from a bio feedstock?
Great. Thanks, Andrew. Another one for yourself, Matt. Is BBT leveraging AI or machine learning at all? And if so, have you got an example of how you're doing that?
Yes. Yeah. So one of the great things about Colab is it's got a lot of machine learning plugins that are there ready to go. It plugs straight into TensorFlow, for example. And there's a range of different things you can do with machine learning, from creating a autonomous car right up to real simple things. And this is a real use case that we've used. We've used OCR to go over our old PDF jobs, and then we've used fuzzy searches to be able to match up our old jobs in our database, so that we can do things like go, how many jobs used a particular anchor, say, that was found to test wrong, and we can put that into the search engine, and it tells us that these 25 jobs used that anchor, and we need to do something about that. We need to go back to those particular jobs and tell them they might want to swap out those anchors. It can also do some interesting things, and we're experimenting with this one at the moment. If you have a database of engineering judgments, you can put those forward. And say the part category example I used before, somebody specifies a part category as P2, we can put the machine learning across the database and be able to say 97% of engineers like you also chose that part category for this type of project. And it's not a calculation, it's a statistical judgment that you can use to know you're on the right track, or at least know how under or over conservative you're being. So there's two.
Nice, yeah, that's good. And it's good to hear about sort of it actually being used in real life, because it's often this strange thing in a report that no one really knows
It's getting to the
how to implement.
it's
So
getting to the point where it's almost as easy as putting a VLOOKUP in a Excel cell. It's almost off the shelf.
Thanks for that, Matt. Sulo, one for yourself. So to keep us healthy in the future, active transport, i.e. walking, running and cycling, should be a major part of transport. How should our cities change to support this?
I think it's two things, isn't it? We need to provide that active modes and importantly that multi-modes, and then at the same time we need to be willing to use them and we need to change our behavior as well. So it's designing the city and urban space to cater for more active modes. At the same time, our personal choices needs to change so that we would embrace them. So I think it's one thing is to design them, and the other thing is to make sure the design encourages people to take them as a choice.
So a bit of give and take, a bit of user, a bit of design.
I think so. I think the design is the lead, and then it should be inviting and encouraging and, helping people to make that as a choice rather than forcing people.
Yeah. No, cool. Got another popular question here for Andrew. Seems like a lot of the large hydropower projects have never made it past feasibility stage, i.e. Project Aqua, Moki Hinui, Hydro, etc. What do you suggest needs to change to get more of these going?
Appetite is the community value. Does it value wind turbines or solar or massive amenity of really?
Hi, Andrew, you're actually,
today.
sorry to interrupt, you're actually cutting out. Andrew, I'm wondering if we just send the questions for you directly, and then we can ask if you can answer those, and we'll send those on an email to everybody.
Yeah, that's all good. I think I did just hear Andrew say, it's about whether the community values it, and that's often why they don't get past that stage. Okay. Next one. What kind of benefit would the engineering disciplines discussed today see from a rework or streamlining of the RMA? Maybe Sulo, this is one you could comment on first, and if Matt or Andrew want to jump in.
I think there's already a lot of discussion and debates going around the RMA as we speak, and I think the technology advancement and the new developments, emerging technology, and importantly the climate change adaptation mitigation, they're all going to contribute to how we manage our resource management, like through Resource Management Act. So that work itself is happening, and so anything we believe it's going to change in the future should be captured and looked at. So the emerging technology will have a role to play, and importantly the climate change mitigation adaptation, I think it has a significant part to play as well.
Cool. Matt, do you have anything to add, or I suppose does it affect much of what you do in BBT?
Regulations play a massive part of it. The Resource Management Act, not so much for us. By the time we're involved, normally the buildings already have their resource consent, but regulation generally and being able to navigate that quickly and easily most certainly has an impact on project profitability, project speed of delivery, all sorts of things. And most of the time we're trying to achieve the same thing. The design engineer is trying to achieve a compliant design, a safe design, and the regulators are trying to achieve a compliant design and safe design. If there's a way they can talk more quickly and easily through technology, then that's definitely something I'm interested in.
Cool. Yeah. There's a heap of questions coming through for Andrew, so I might just ask Andrew one, and he can type it, and I'll read it out. Does Transpower consider decentralised solar microgrids a viable option for New Zealand's distribution network, i.e., usable and can connect to the HVDC? Sulo, one for you. Is building roads the right thing to do? Would train lines be more sustainable and environmentally friendly? I'm guessing so. But
yeah, I think that's quite right. So we are not building. So importantly, New Zealand Transport Agency, Waka Kotahi, is not in the business of building roads anymore. It's more about connecting people with people, places, and moving products. So we are not simply building roads. It's more about mode neutral, multimodal, and making sure it's more system-wide and outcome-focused. So the building roads is an old school that, we thought that by building more roads, more things could be moved and, it can serve more demands, but that's shifted now. So that's no longer in our business case. So the business case looks at everything openly.
Yeah, and I assume aligns with the better business case and all that stuff about social value and climate and that sort of thing. We've got another one actually for you, Sulo. Someone says, I agree with your slide, what are the outcomes, but I also think cost efficiency is key, especially from a customer perspective, so to encourage uptake, etc. Is that aspect part of future planning?
I think any time in the past and also I believe in the future, the affordability of our infrastructure and everything we have around us is really key. But if we have limited funds and limited budget, the way to manage that is prioritizing and making sure we spend the money at the right place. So we need to apply, there are quite a lot of enablers we have at the moment. So we have the good tools, emerging technology, and we have the great brain power, and we have everything available to us to make decisions very smart and sharp.
Cool. Potentially one for yourself, Matt. With the present COVID situation, do you think that New Zealand can grow more in terms of potentially completing more engineering projects without having the required skilled manpower inside the country? I suppose it's similar to the previous question about offshoring, but have you seen a shift?
We're stretched at the moment, and that the borders, the effect. It turns out that the construction industry runs on a lot of immigrant labour in both the high technical and construction workforces. And there's an awful lot of pressure on at the moment. that's one of the reasons the current COVID situation is driving us to automate. If we can get even 2 times the work out of each engineer, that's worth looking into. So yes, it's having an impact, and maybe technology can help us there.
Have you seen the change in Waka Kotahi, Sula?
I think, yeah, the resource is an issue, and also in construction, we also have quite a lot of material imports affected by COVID as well. And if you look at the main material supply, most of them, especially steel, comes from China and South Asian countries, so that's affected, and then the price goes up, and very difficult to resource, long lead times. So these all are factors beyond you would normally have contingency for. So it has affected, yes, yeah.
Do you think it will, it will sort of change how the industry works in the future?
I think when we look at the material choice is a decision point in terms of what material to use, and so over time it will change, new materials emerge, but it's very difficult to predict at the moment because it's not just affecting a country or two, it's a global issue. So we need to come up with ways to manage. Yeah, sure.
Yeah. Yeah.
There's no one answer here, is it? So it's a combination of things, yeah.
Yeah, definitely. Got another one here. We're almost out of time, so this may be the last one. But Sulo, what are your thoughts on the decrease of vehicles due to better transportation, like Hyperloop, for example? And is New Zealand moving towards that direction? I suppose I think it's trying to say, is it better to invest in public transport to decrease individual use vehicles?
Yeah, I think transit type of transport modes, public transport, they are the future, and we also have different operating models, for instance, Uber and other, operating models. So there's quite a lot of changes happening, and I think one of the things is spanner in the works is COVID. And now we can feel and we can imagine what we look like in the future when we navigate through these tricky times. So we should be prepared for anything, right? So look at now, we wouldn't have done this 2-3 years ago, a very big a seminar or technical talk all happening on webinar, So, there would be technology making all these possible. So I'm hopeful, and I'm sure that all of you here are hopeful and contributing to better outcomes for us in the future.
Yeah, I hope so too. And to be honest, I would have said a couple of years ago you wouldn't have got 450 people tuning into a webinar. So I suppose that's how things have changed, haven't they? Well, thanks so much, Sulo and Matt, and Andrew, if you're still on the line. But and thanks obviously so much to all those people who tuned in. Sorry for some of you obviously have experienced sound issues. Hopefully I've been okay, but we'll post other questions and hopefully the slides later on. So hopefully we'll get through all the questions. We didn't quite get through all of them, but there were plenty for Andrew that unfortunately we couldn't really answer. But thanks so much both to the presenters and for you guys for tuning in. Thank you.